I believe I forgot last time, for which I apologize. All right, 5-4 is about nonlinear systems. That's a terrible, terrible name. It's like talking about non-elephant animals. There's just so much variety. These are systems which are sort of kind of linear, only we have some x squareds and y cubes instead of x's and y's. So we'll use similar methods as linear systems, substitution and elimination. And then we'll have to take some square roots. So for example, x plus y squared equals 0 and 2x plus 5y squared equals 75. Okay, this is one which we can use substitution for, because x plus y squared is 0, therefore x equals negative y squared. Then we can substitute into here. So 2x plus 5y squared equals 75 means that this is negative 2y squared. Then the plus 5y squared equals 75. So 3y squared equals 75. So y squared equals 75 over 3, which is 25. So y equals plus or minus root 25. So y equals plus or minus 5. So x, which is minus y squared, is negative 25. And so there, here your answer is negative 25 by plus or minus 5. Two solutions. Here we have two equations, which I suppose correspond to two parabolas meeting somewhere. X squared minus 2y equals 1. X squared plus 5y equals 29. Okay. Therefore, subtracting equations, we get that. So this equation minus this equation, the x squareds cancel. Minus 2y minus 5y equals minus 7y. 1 minus 29 is 28. Negative 7y equals 28. So y is negative 28 over negative 7, which is 4. So plugging back in here, x squared minus twice y is 1. So transpose of twice 4. So x squared minus 1 plus 2 times 4 is 1 plus 8, which is 9. So x is plus or minus root 9, which is plus or minus 3. So the solutions are plus or minus 3 by 4. Here we have x squared plus y equals 0. X cubed minus 2x minus y equals 0. Well, okay, first, from the first equation, y equals x squared. Then substituting into the second equation, x cubed minus 2y minus negative x squared is 0. Okay, one equation and one unknown. Rewrite that as x cubed plus x minus 2x is 0. Factor this fully. Common factor of x comes out. The rest factors into x plus 2 times x minus 1. So x times x plus 2 times x minus 1 is 0. So either x is 0, or x plus 2 is 0, or x minus 1 is 0. So x is 0, or x is negative 2, or x is 1. Using y equals negative x squared. If x is 0, y is 0. If x is negative 2, y is negative 4. And if x is 1, y is negative 1. So the three solutions are 0 by 0, negative 2 by negative 4, and 1 by negative 1. Okay, page 3. Okay, here we have, let's see, x minus 2y is 2, x squared minus y squared is 2x plus 4. This is a line. This, I guess, is a hyperbola. So what does a line mean, a hyperbola? Okay, from this one, first we solve for x. X is 2y plus 2. Substitute into the second one. Y squared minus the square of 2y plus 2 equals twice 2y plus 2 plus 4. Okay, this needs some expanding and transposing. And finally, we get to minus 3y squared minus 12y minus 12 is 0. Okay, this we can factor out a negative 3. Y squared plus 4y plus 4 is 0. This factors into y plus 2 squared is 0. So y plus 2 is 0. Well, plus and minus 0, but that's where you get coincidental roots. So y is negative 2. And plugging into x, x is twice negative 2 plus 2, which comes out to be negative 2. Solution is a negative 2 by negative 2. Now, for 41, they ask, we have a rectangle with area 180 square centimeters and perimeter of 54 centimeters. All right, so area is x times y equals 180. The perimeter is 2x plus 2y equals 54. All right, xy equals 180, 2x plus 2y equals 54. For this one, we can divide by 2 and get x plus y equals 27 and x, y equals 180. Now, I could use this to create a quadratic formula, which you then try and solve by factoring. But to factor, all you really need is to find which factors of 180 add to 27. So all you really need is just to go through the table directly without having to go through the quadratic formula or the quadratic. And look for the various values of 180. Factors of 180. If x is 1, y is 180, sum is 181, no good. 2, 90, 92, no good. You keep going. 3 doesn't work, 4 doesn't work, 5, 6, 7, 8, 9, 12 works. If x is 12, 180 minus 12 is 15. They add to 27, and we are done. We'd be going through this exact same process if I took a detour onto a quadratic equation. So here we go. The rectangle is 12 centimeters by 15 centimeters. Okay, I think that concludes that.